Hi everyone, my name is Courtney Krystek and I'm going to be presenting today on dark matter and dark energy and its nature in the universe. Now, using Einstein's theory of gravity, when we started embarking on our space explorations, there were certain things that we expected to find in the universe. For one, we didn't expect the universe to still be expanding at the rate that it is today. Now, a lot of theories surfaced once we discovered this, and one of them was that of dark matter and dark energy. Now, the dark matter and dark energy theory states that there is a form of matter whose properties we don't quite know yet that is acting on the universe, in all the stars, and it's affecting their movements in certain ways. In fact, there's even an idea that about 80% of the universal material is made of this, and only 20% is the visible material, as you can see on this graphic here. Now, the interesting thing about dark matter is that we haven't been able to pinpoint exactly what it is, but we have been able to pinpoint exactly what it isn't. So the good and the bad there. We've done many experiments and run many hypotheses into probing what dark matter could be, such as antiparticle analysis, and different experiments like that. Since it's not visible to us, we're not able to use the regular methods of understanding we might otherwise use in astrophysics, such as looking at the temperature, the color, these kind of properties. So the way that astrophysicists today and in the modern research field have been probing dark matter to try to understand more of its properties and more of how it affects our universe is by looking at how it interacts with the visible objects that we can measure, that we can see. And by doing it in this way, we're still able to get the statistical data that we need in order to see, yes, this is having an effect and this is what it is doing, this unseen force. So it enables us to back up that hypothesis that, dark matter does exist, and it allows us to guess more at its properties. One especially interesting study that I'm going to be discussing in this presentation is looking at binary pulsars and how dark matter interacts with their movement. There's evidence that has surfaced through observing two binary pulsar sets that I'm going to go over, and the effect of dark matter seems to be modifying their movements. There's a scenario called the double disk dark matter scenario, and it looks at the curve of their movements around each other, and they're not moving how we would expect. And by analyzing this, we can suspect that part of it is due to the dark matter and the dark energy that we can't see. And by looking at the visible effect of it, we are able to better understand how it's operating in our universe, because dark matter and dark energy not only affect these distant stars and encompass our imaginations as to what the cosmos is built of, but it's the very fabric. It could be the very fabric of the universe. It could be a property that we have yet to really delve into, just as gravity is here on Earth. So that's why it's so important and interesting to understand and to make sense of. So I look forward to, in a few weeks, doing the rest of my presentation. All right, thank you for listening.